Let's take a look at this problem. This problem is trying to show us that the formulas like sine, cosine, and tangent are useful for finding missing measurements beyond the math classroom, not just for solving for x in a triangle. Let's read this together. It says, Robert is standing 250 feet from a building and looks up at an angle of elevation of 65 degrees to see the top. If Robert's eyes are 5 feet above the ground, how tall is the building? The best way to start this type of problem is by drawing a diagram. I recommend that whenever you have multiple objects in a real world type problem, that you draw the ground first. In most cases, if you draw the ground, then all the other objects are connected to the ground, and you can draw a more reasonable picture that will help you solve the answer more easily. So let's pretend that this right here is the ground, which means the building and Robert are on that ground. Let's draw the building. So we have, let's pretend that this is our building that Robert's looking at. And it says that he's standing 250 feet away from that. So we go a distance away and we have Robert, he's over here. Now we know that one of the measurements we can label is the 250 feet. That would be the distance along the ground from the person to the building. So let's label that right away as 250 feet. Next, it says that he looks up at an angle of elevation. An angle of elevation, the word elevation means that he is looking upward, like an elevator. So imagine if he's looking straight ahead and then tilts his head upward. That would be the angle of elevation. So let's draw that in. We have him looking forward, okay, and then he tilts his head upward to look at the top. And so we tilt his head upward and he looks toward the top of the building. That angle that he created, that's the angle of elevation. So let's put the 65 degrees right there in that corner. Next, it tells us that Robert's eyes are 5 feet above the ground. So that would be like the gap between this line and the ground, or the height of the person, or this gap over here. Let's label it right by his eyeballs here, 5 feet. And then it asks us, how tall is the building? So our goal is to figure out the height of this building right here. I'm going to label that just right here. Let's call this h for the height. Now, to do this, we're going to use trigonometry. Okay, and the reason why we're going to use trigonometry is because once we've drawn this diagram, I notice that there's a triangle. And we can use trigonometry in triangle problems. Here's the triangle. I'll highlight it momentarily here. This triangle is the one that we're going to focus on. And this is a right triangle, so we can use things like sine, cosine, and tangent. And so let's do it. We're going to find the formula to pick, and we can figure out which formula is the best one to use by labeling this triangle. I'm going to get rid of the highlight for a moment. So let's just break it down one side at a time. This is a right triangle. That's important because sine, cosine, and tangent work in right triangles. Then we're going to label theta. Theta is one of the two acute angles of the triangle, and we want to pick the corner that has the angle measurement, the 65 degrees. So that corner is theta. Then we need to label the three sides of the triangle. So the first side we're going to label is the hypotenuse. And so the hypotenuse is the long side of the triangle. That's this one because it's across from the right angle. Next, we're going to label the opposite side. The opposite side is always across the triangle from theta. And this is the side of the triangle that we care about because this one represents part of the height of the building. So I'm going to call this x as well because that's what we're trying to solve for. And we're going to label it as the opposite side. And then lastly, we have the adjacent side. The adjacent side is the last side of the triangle. That's this one right here. And so we have adjacent. Okay, so let's identify which two of the three sides are actually useful. One of them is not. So I noticed that the opposite side is useful because that's the letter x. We're going to use that in the formula. And then the adjacent side is also useful. The adjacent side of the triangle is the 250 feet. Both the ground and that side of the triangle are both 250 feet. And you can explain that by noticing that this is a little rectangle below, and we know that the bottom of a rectangle and the top of a rectangle are the exact same measurement. The side in the triangle that's not useful is the hypotenuse, and we're going to ignore the hypotenuse because that's the blank side. So now that we know that the two important sides are the O for opposite and A for adjacent, we need to figure out which formula uses O and A. If we look at this memory trick is sohcahtoa. It's how we remember the three formulas. We need to just look at each of the three formulas and decide which one has the correct letters. We are looking for O and A. So it's not sine, it's not cosine. We're going to use tangent. We're going to use tangent because it has the O for the opposite and the A for adjacent. So let's pick that formula right there. So we need to write down the tangent formula. Let's do this. We are going to be using the normal tangent formula because we are solving for a side length of the triangle. If we needed to solve for a corner or an angle, then we would use inverse tangent. In the parentheses goes the measurement for theta. Then after the equal sign is a fraction, we would use the opposite measurement on top, and the adjacent measurement, A for adjacent, goes in the denominator. Let's rewrite this formula with the measurements in the formula. So we have tangent. We'll leave some blanks for where we're going to write the measurements. So we have the theta is the 65 degrees. We have the opposite is x, so that's what goes in the numerator. And then we need to put the adjacent, that's the 250 feet, that goes in the denominator. So now we can solve for x. Remember, solving means get x by itself, and to do that, the fastest way is to cross multiply. We can cross multiply when there are two fractions equal to each other. So we do need to make the left side into a fraction by placing it over 1, and now we can cross multiply. 1 times x and tangent times 250. So let's write that down. We've got the first diagonal, we'll do the 1 times x. So we have 1 times x. And then we bring down the equal sign. And then the other diagonal is the 250 times tangent. 250 times tangent, and the 65 is connected to the tangent, so that's going to go with tangent, and then in the parentheses 65. All right, this is good because this has isolated the variable. 1 times x is just x. And now that the variable is isolated, we can go to our calculator and type in the 250 times tangent 65. So let's pull up our calculator. In the calculator, for this to work, we need to make sure our calculator is in degree mode. If you're using a TI calculator, you can click the mode button and check that the word degree is highlighted. Click clear to exit out of the menu, and now we can type in 250 multiply by tangent 65. So we use the tangent button, and then in the parentheses 65, and when we hit enter, this is the result for x. So for x we have 536 point, and we're going to round to the hundredth, so we have 0.13. 536.13. All right, now this is the measurement for x. What we just solved was this blue side of the triangle. Now notice we're not quite done with the problem yet because we're trying to figure out the entire height of the building, and the blue side of the triangle is only most of the height. Notice how there's a little gap at the bottom that isn't quite the full height of the tower. So what we need to do is we need to combine the 536 with a little bit more so we can get that full total height. And that gap, let's recall, it says in the question that Robert's eyes were 5 feet above the ground. That gap is the 5 feet. So let's add the 5 feet to our x. We need to add 5. And so that means the total height would be just 5 more, right? So that'd be 541.13. Our units for the answer should be in feet, right? Because our question tells us that the measurements are in feet. So I'm going to put that on my answer, 541 feet. and that is our answer. I do want to point out that this is the height of the total building, 541 feet. There's also a quick trick that you can use to avoid the cross multiplication. When the variable is on the top of the fraction, that indicates that you're going to be multiplying in the calculator. If x had been on the denominator of the fraction, then we would divide in the calculator. That's all for today. Like and subscribe.